Hello and welcome to the course of Computer Network Part 2. Today we are going to discuss about multicasting routing, and in the last lecture we discussed about broadcasting. There are three things in this routing. The first one is unicasting, second is broadcasting, and the third one is multicasting. So we all are about the first two things. Unicasting means when an individual node called source in the network sends some information or messages or data packets to an individual destination in that particular network or outside that network is called unicasting when you talk one to one. Second thing is broadcasting. When in a particular network, a particular node called source would like to send their data packets or information to all the nodes present in that particular network is called broadcasting. And in the last lecture, we saw how we can uh, provide broadcasting, or how we can how a node present in a network can broadcast the information to the whole network with the help of spanning tree. Now today we are going to see how multicasting is done, but before that we should know what is multicasting. Multicasting is nothing but when an individual node called source inside a network would like to send data to a specific group of nodes, not to all the nodes or not to a single node, but to a specific group of nodes, then it is called multicasting. But as we all know that IP, we all have seen IP header, IP version 4 header, which has got two important fields or two IP version 4 fields. The first one is used for source IP address and the second one is used for destination IP address. So in IP version 4, we have got only one destination IP address field. So it's good for unicasting. If you have to send a data to a particular node, then you can put that particular node's IP address in that particular field, destination IP address, and you can send the data easily. But in case of broadcasting, as I told you that there is a universal broadcast address called 255.255.255.255. Whenever a node finds that address in its destination IP address field, then that node has to broadcast that particular packet to all the other directly connected nodes to that particular node. So it's quite simple, and for the smooth process of broadcasting or for effective broadcasting, we found that spanning tree is one of the best way. But now today we are going to see multicasting, and in multicasting a node has to send data to a specific group of nodes present in a network. Then in that case, in IP version 4 destination field, we can put only one IP address. So how can we create a group of nodes, and how can we send data to those particular nodes which are residing in that particular network and they are the part of a group? So in that case we have to use class D address. When we were at the network layer and when we were studying about IP addressing, then we discussed about the classful IP addressing, that 2 to the power 32 total number of IP addresses are divided into 5 classes: class A, class B, class C, class D. Class D IP addresses basically are used for multicasting, and we take a class D IP address and we form a group of IP addresses to provide class D IP address as one IP address to that particular group of IP addresses. Uh, let's suppose we have got this particular network and these red nodes are the part of a particular group. So we need to form a group, and in that particular group we need to have these nodes IP addresses. So what we'll do, we'll take a IP address from class D and we put all these IP addresses in that particular class D IP address group. So on behalf of these four IP addresses or these four nodes, only one IP address of class D will represent these four nodes or these or a group of these four nodes. So I hope it's clear to you guys that if you have to multicast a particular information to a particular group of nodes, then you have to create a group, and for that group you have to take class D IP address and put all the IP addresses of that particular node which are the part of that particular group in class D IP address. So class D IP address will represent all these four IP addresses, or I should say class D will represent a group of these four nodes. So if you have to send the information, if a node present in a network called source has to send information to a group of nodes, then that particular node will first of all create a group, and it will take class D IP address to represent that particular group, and whenever that particular node has to transfer that information to that particular group, that particular node will put class D IP address in destination IP address field, so that that particular message or packet can reach to that particular group. In that case, these routers which have the group members must know about the group, and we need to create a tree for sharing that information. So the basic idea behind multicasting is when you, in a network, when a source node sends information to a particular group, for creating that group we need to have class D IP address, and in that particular class D IP address will form a group of and we put the group members in that particular IP address which will represent that particular group. So that is how it's going to be done. And for disseminating or that particular message to a multicast group, we need to form a tree. As you can see that we have got this tree for these four group members. You can see these red lines are shown, and this is a tree which we need to create. And these for multicasting, these tree can be of two types. First one is shared tree, same tree used by all group members. Shared tree are those trees, or I should say shared tree in a network is a tree which is used for all the group members present in that particular network. Let's suppose if it is a shared tree, then this particular tree will be used by either of the group member, like this one, this one, this one. This tree can be used by anyone, and there will only be a single tree for multicasting. But if there is another way for multicasting or disseminating your information to a particular group, is called source based tree. So every source is got a different tree for each sender to receiver. As you can see over here that we have got blue tree, we have got green tree for different sources. So multicasting can be done with the help of types of trees: shared tree, which will be a common tree for all the group members, and the other type is source based tree, which can be like whatever number are there for the nodes. Each individual node present in a network have to have that particular source based tree to disseminate its information to that particular multicast group. So now you can see approaches for building multicast trees. As I told you in the last slide that we have got two approaches: source based trees, and in source based trees, one tree per source. And these source based trees can be created with the help of shortest path trees. As I told you earlier, that shortest path protocol, for finding the shortest path, you can use distance vector, link state, and reverse path forwarding can be used for creating source based trees. And this reverse path forwarding we have already discussed in the last lecture. Um Now the second approach is group shared tree. Group uses one tree. There's a single tree, for a group of uh, for a particular group. Whatever members are there inside that group, they all will use the same tree, and that tree can be created with the help of minimal spanning, as we have already discussed spanning tree in our broadcasting lecture. So the same type of tree can be used in multicasting, but that should be a minimal spanning tree, which is used by all the group members. So they'll never be a separate tree for a particular source in group shared tree approach. We'll use a single minimal spanning tree for sharing or disseminating the information to our multicast group members. And the second approach for creating group shared tree is center based approach. As we have already discussed this approach in our last broadcasting technique, in which I told you that you have to choose a center router, which is also called a Randivis router, which is used for again creating a spanning tree. So let's see how these trees are created. The first approach is source based tree. So how you can create a source based tree with the help of shortest path tree? As I told you earlier, that Dijkstra algorithm, which we have already discussed in our starting lectures, that this particular algorithm is used for finding the shortest path between two nodes present in the network. So it's a simple network, and if you know your group members for a multicast group, then you will you can use Dijkstra algorithm to unicast those messages to your multicast group members, and you can form a tree. It's very simple. It's very simple. You can use Dijkstra's algorithm, and you can find a shortest path between two nodes, this one and this one. Let's suppose R1 and R6. You can find the shortest path between these two nodes, and once you are done with the shortest path, then you will create those branches as a tree branches, and you will form a shortest path tree using Dijkstra's algorithm. It's very simple. And once you are done with the tree, then you can use that tree for sharing or disseminating your information to your multicast group. The second approach for source based tree is reverse path forwarding. So in reverse path forwarding, rely on router's knowledge of unicast shortest path from it to back to the sender. Each router has simple forwarding behavior. If multicast datagram received on the incoming link on the shortest path back to the center, then only it will disseminate its information to the outgoing link. Otherwise it will ignore the datagram. It clearly says over here that multicast datagram received on incoming link on shortest path back to the center, then flood datagram onto all outgoing links, else ignore the datagram. So these are the two approaches for for creating source based trees for multicasting routing. Now reverse path forwarding, let's check these things out. What it says is result is a source specific reverse SPT, and it may be a bad choice with asymmetric links. If you find asymmetric links in your network, then this reverse path forwarding may be a bad choice for you. So you have to use the first one. And Pruning is there. Pruning is nothing but when you ask your upper router that I do not have any group member, so do not transfer the multicast messages to me. It simply says that reverse path forwarding. Pruning is nothing but forwarding tree contains subtrees with no multicast group members. So no need to forward datagrams down substream. Prune messages sent upstream by the router with no downstream group members. So here you can see that in this particular network, this is a tree which we have formed, a source based tree. This is the source and it has created a tree for its group member. But unfortunately, this R7 router lost their group members, or there may be any reason that this R7 router doesn't have group members anymore. So this R7 router will send a upstream prune message sent upstream by the router with no downstream group members. So R7 will send the information to R5. As you can see this thin line which says prune message, you can see this thin line over here. R7 will send a prune message to R5 and R5 will inform to R4 that we do not have group members anymore and you're not supposed to send your messages to us because that the task or that effort will be in vain. So that is how this pruning message or pruning process is used for letting the upper routers know that we do not have any group members and you're not supposed to send the multicast group data to us. Now the second approach for multicasting is shared tree, and you can see the first approach for shared tree is Steiner tree, and which is not very effective as it says. So minimum cost tree connecting all routers with attached group members. Problem is NP complete. It has got excellent heuristic existence, not used in practice because of computational complexity. Information about entire network needed. Got the point? And the third thing is monolithic. Rerun whenever a router needs to leave or rejoin or join a particular multicast group. So there are some problem with this approach, but the second approach for creating a shared tree is center based approach, which we have already discussed during broadcasting. And the center based approach is used for creating a spanning tree, single delivery tree shared by all, and one router identified as a center a, of a particular tree or a particular network. To join edge routers which have the group or multicast members, send unicast join message addressed to center router. Join message processed by intermediate routers and forwarded towards center. Join message either hits existing tree branch for this center or arrives at the center. If it hits the existing tree branch, then it will not forward the packet to the center router because that particular join message has found a particular branch of that particular tree. Path taken by join message becomes new branch of tree for this particular router. So center based is very simple and it is the same approach which is used for creating spanning tree in the broadcasting process. So once you have a tree which is connecting only those routers present in a network which have the multicast group members. Once you have that type of tree, then you can easily send the information with the help of that class D multicast address which I have told you at the start of this particular lecture. So that is how you're done with the uh, multicasting process. Now in this particular slide, you can see center based tree example. Suppose in this particular network which has got 7 routers, you have chosen R6 as a center router or a rendezvous router or a center router for this particular network. Now you're going to create a tree for multicasting group. So how you're going to create a tree for a multicasting group is this: all the members or all the routers which have the multicast group members will send a unicast message to this particular router, or tree join message to this particular router, as R3 sends a message to this particular router, and this particular branch will become the part of that tree. And as R1 as R2 is sending to R6, this particular branch will become the part of that particular spanning tree. And once this R1 router will send the information to R4, and R4 already made this particular link as a part of that particular tree. So R1 has to send that particular unicast data to R4 only, and this branch will become the part of that tree. And this router is already having a branch of that spanning tree. So message from R1 uh, doesn't require to reach to this R2 router. So it's enough to send a message to a particular router which has got a spanning tree branch. So that is how you create a spanning tree for multicast group through a center based approach. And once you are done with this tree, you can easily disseminate your information with the help of class D address, which represents the complete group members of that particular multicast group. So that is how it's done. And the protocol which we used for multicasting is this. It stands for distance vector multicast routing protocol. It comes under RFC 1075, and this is the protocol which is used for providing multicasting. So thank you very much. In the next lecture we'll see our next topic, and if you have any problem, you can call me, email me, contact me, or we can discuss problems in our interaction classes. Thank you very much. Have a good day.